Hello everyone. In this video we are going to discuss about relational algebra in DBMS. This is the outline of this video. This video consists of unary relational operations, Cartesian product, set operations and joins. Unary relational operations. There are total 3 different types in unary relational operations. First one is selection. The selection operation is basically used to filter out the rows from a given table based on certain given conditions. It basically allows us to retrieve only those rows that match the condition as per condition passed during SQL query. This is the syntax of the selection operation. It consists of a sigma followed by a selection condition and a relation. Now let us clearly understand with an example. Let us consider a relation or a table named student. It consists of different attributes like a name, roll number and age. Now if you want to retrieve the entire record or a row whose roll number is 22, observe the bottom leftmost bottom picture. The syntax is sigma followed by roll number is equal to 22 from student. Then it retrieves the entire row of the record of this table. Now observe the example 2. We want to retrieve the person whose name is Sai and as well as the age is 18. This selection operation is used to retrieve duplicate values also. Like Sai is observed 2 times. It can retrieve 2 times. Now the second type in unary relation operations is projection operation. While selection operation works on rows, similarly projection operation in relational algebra works on columns. It basically allows us to pick specific columns from a given relational table based on the given condition and ignoring all the other remaining columns. In selection operation, we can retrieve only rows, but in projection operation we can retrieve the entire column. Here rows cannot be retrieved. Let us observe with an example. Understand with an example. Let us consider the same table named student. The basic syntax is phi, comma in bracket name, comma age. We want to retrieve the name column and age column from student. Observe the example to understand clearly. Now the third type is rename operation. Rename operation basically allows you to give a temporary name to a specific relational table or to its columns. If we want to change the table name temporarily or the column name temporarily, we use rename operation. Observe the syntax. Now the second type in relational algebra is Cartesian product. The Cartesian product combines every row from one table with every row from another table, producing all the possible combinations. The basic syntax is relational 1 cross symbol with a relational 2 relation 2. Let us understand with an example. Consider this example where student has the 2 records whereas a project table has a total 4 records. While performing Cartesian product on these 2 tables, the total result obtained is total 4 into 2, which is 8 records. Observe the example to understand clearly. Now the third topic is set operations. There are total 3 types of set operations. First is a union, second one is intersection, and third one is set difference. Let us observe union. The union operator is basically used to combine the results of 2 queries into a single result. The basic syntax is a table 1 union symbol with table 2. Let us consider 2 tables A and B, where A has a 1, 2, 3 records and B has 3, 4, 5 records. While performing union operations on these 2 tables, their duplicate values are retrieved only once, whereas the remaining values are all all retrieved. Observe the example to understand clearly. The second one is intersection operation. Set intersection basically allows you to fetch only rows from a data that are common between the two sets of a relation table. The basic syntax is a table 1 intersection table 2. Now let us consider same two tables where A has 1, 2, 3 and B has 3, 4, 5 values. While performing A intersection B, only the common between two tables are retrieved, that is 3. 3 is common, so it is retrieved while performing intersection operation. The third type is set difference. Set difference basically provides the row that are present in one table but not in another table. It is basically performing minus operation. Now let us consider two tables A and B where A has 1, 2, 3 values and B has 3, 4, 5 values. The basic output is 1, 2 because 1 is not present in B and 2 is not present in B, so they are returned. But 3 is present in both A and B, so it is not returned as output. Now the fourth concept is joins. Join operations in relational algebra combine data from two or more relations based on their related attribute. Different types of joins include inner join and outer join. The joins are used to perform operations on two different types of tables. Let us consider two tables. First one is DEPT, where DEPT has department number, DName and LOC means location. Let us consider a second table name EMP, employee. It consists of four different attributes like employee number, ename, job, MGR and department number. Now let us perform different types of join operations using these two tables. The first type is inner join. Inner join consists of three different types of join. First one is Equi Join, second one is self join and third one is natural join. Equi Join, a join which contains an equal to operator in the joins condition. Now if we want to retrieve the table where employee ID is equal to department number, this is the basic query. Select employee number, employee name, job, DName, LOC from employee table and department table where E.department number is equal to D.department number. We are checking whether the department number in employee table equals to department number in department table. If both are equal, we will return the employee number, employee name, job, DName and location of that current employee. Observe this here, department number 10 in EMP is equal to department number of 20. So this entire record is returned. Likewise followed by remaining two records. The second one is self join. Joining the table itself is known as self join. Here only one table is performed in this operation, whereas it is joined within itself. This is the syntax of a self join using those two tables, using the employee table. Select e1.employee, e2 is second table, e2.ename, e1.job, e2.department number. From employee e1, emp e2, where e.dot and e.dot number is equal to e2.mgr. If employee number equals to e.mgr, then the values are returned like employee name, employee number, which are there in select function. Now the third type is natural join. Natural join compares all the common columns. Now if we want to return the common columns, we use natural join. This is the syntax. SQL query. Select EMP number, ename, job, DName, LOC from EMP natural join department DEPT. While performing both operations, the common columns are returned. Like here, department number 10 equals to department number 10 in department. Now the select has some values, those are returned. In the same way, department number 10, the third column has department 10 in employee and the department 10 in first column in department. These values are returned. Now the second type in joins is outer join. Outer join also consists of three different types. First one is left outer join, second one is right outer join, and third one is full outer join. Left outer join. This will display all the matching records and the records which are in the left hand side of the table, those that are not in the right hand side of the table. Now this is the SQL query where select EMP number, ename, job, dname and LOC. From employee left outer join DEPT D on E dot department number is equal to D dot department number. Here leftmost table is EMP, whereas the rightmost table is a department. Here note that in a left outer join, the leftmost table all the values are recorded, whereas only some of the values are recorded in a rightmost table while performing a left outer join operation. See here, employee number 111, 333, 222, 444. All the four values from the employee table are recorded, and the remaining null values of the department table are not recorded in the right hand side of the table. The second operation is a right outer join. This will display all the matching records and the records which are in the right hand side table, those that are not in the left hand side table. This is the SQL query where select enumber, ename, job, dname, LOC. From EMPE right outer join DEPT D on E dot department number is equal to D dot department number. Here the rightmost table is DEPT, where leftmost table is EMP table. Here all the values in the department table are recorded, whereas only some values matching the condition from the employee table are recorded. Let us observe the example. Here department consists of four values: inventory, finance and HR. Inventory is repeated two times because the employee number 10 repeated two times. See here, employee number repeated two times. This is a right outer join.